In today's lecture, we're going to explore the concept of pedigrees. Pedigrees are defined, look at that, we went technical definition, as an ancestral line, a line of descent, lineage, or ancestry, or a genealogical table, chart, list, or record. And what we're going to be focusing on is actually this part of that definition. A genealogical table, chart, list, or record. What a pedigree is it is a scientific representation of an organism's family. And that's actually what it says up here, like a genealogical table, chart, list, or record, an ancestral line. What we're actually doing is we're representing an organism's family. And what we can do is use our knowledge of both genetics and the family to both solve problems and make predictions. And obviously, when we're working with science, one of the most important things that we can do is make predictions. And so pedigrees are really useful for real-life jobs like a genetics counselor. So you can take a look at your family history of certain disorders and see what your chances are of passing one of those disorders on to your child. And also, it's great in a historical context for us to take a look back at different organisms or different families and see what sort of genetic traits have moved through them. So the first thing to think about is this is a pedigree. I'm sure most of you have seen a diagram that looks like this in the past. And the key to any type of diagram is, as always, understanding what all the symbols mean. So that's what we want to start with today, is we want to start with the symbols, okay? So before I get into the symbols, let's talk about the numbers. Apparently we're not starting with the symbols. So you can see, get rid of this because it drives me nuts. Okay, so you can see here, here, and here. What we have is a Roman numeral. And what those Roman numerals represent is the generation that we are looking at. Obviously, this first generation has people that gave birth to them. The only way to get life is from other life. But this is the generation we are looking at. So for our pedigree, this group right here is our first generation. This group right here is our second generation, and this group right here is our third. Now you'll also notice that at the bottom of the pedigree there are numbers. So there's 1, 2, 3, 4 in the first generation, and you'll notice that they reset. So there's 1, 2, 3, 4, 5, 6, 7, 8 in the second generation. And then there's also 1, 2, 3, 4, 5 in that third generation. So within each generation, we have numbers that represent the people. What's more technical is the organisms that are in that generation, okay? Now, let's actually get into the symbols, all right? So circle, so like right here, that is a female, okay? Square, right here, those are males, all right? A line like this implies that that female and that male are breeding, all right? So they are parents, and they are parents of everything that comes off that line. So that means that on our little diagram here, these two, generation 1, individuals 1 and 2, are the parents of generation 2, individuals 1, 2, 3, 1, 3, so they are the parents of 1, 3, 5, 6, and 7. You can see how 2 is not connected to the line. 8 not connected to the line, 4 not connected to the line. That's because they marry into the family, if you will. If you give me a second, I just need to clear this up so it doesn't look so messy. All right. So what you'll find, all right, is that here we have an individual colored in. And that means that this individual possesses our trait. What trait? It doesn't matter, all right? Usually you will be told the trait. It's not like you look at a pedigree and know what the trait is. You have to be informed of what that trait is. So those individuals possess the trait, okay? Occasionally you will see pedigrees, and this is not a consistent thing. So sometimes you'll see pedigrees where there is an individual that is half colored in, okay? Well, that was weird. So someone who's half filled in, that person carries the trait, which typically means that they are heterozygous, which is a term that we should be familiar with from our work with genetics so far. Let's see, what else? We did discuss how this line that I'm tracing in red right now means that every one of these people connected to that line are the offspring of those parents. And I think that might be all the key terms here. All right, so we have male is square, female is circle. If you are colored in, it means that you have the trait. If you are half filled in, like we had down here with 5, that means that you carry the trait. This line that we've shaded in red right here means that you are offspring. All right? Excellent. So let's talk about some terminology. All right? So the pedigree itself is generally what we refer to as the chart, okay? You will frequently see with pedigrees the term autosomal dominant, okay? Now, if you remember, autosomal are those chromosomes you have that are not sex-linked chromosomes. If something is autosomal dominant, that typically just means simple Mendelian dominance. Okay? Now, if you see the term autosomal recessive, I'm pretty sure you can guess that that will mean simple dominance again, so it's simple Mendelian dominance. But in this case, what we're watching move through the family is the recessive trait. Okay? You also will frequently see some other terms that we've used, commented on. You will see pedigrees where they say that the trait is sex-linked. You'll see pedigrees where they say that the trait is codominant. You will see pedigrees where they say that the trait is incompletely dominant. And these are exactly the same as what we've already talked about in class. So it's not like you need to feel like you need to learn something new to understand that concept. All right. So the real thing about pedigrees is frequently you will be given a pedigree, let's say an image like this, and you will be asked, is this autosomal dominance? Is this autosomal recessive? Is this sex-linked? Frequently, you will be given a pedigree like this, and you'll be asked to give the genotype of the individuals. So let's just do a couple of examples. Obviously, we'll go over some more of these in class, but just to give you a start. So here you have a pedigree. You'll notice the generations are numbered in Roman numerals. See that here, 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 and here. You'll notice that the individuals are numbered as well. I'm not going to circle those because there's too many of them. All right, you see the connecting lines we talked about before, and you'll notice that some people are shaded in. So let's take a look at this person right here, number 2. So number 2 is one of the offspring of generation 1, 1 and 2 as parents. So these two are this person's mother and father. All right. So you will notice that the mother and father do not have the trait. And you will notice that offspring 2 has the trait. But 3 doesn't, and 4 doesn't. Okay? So one of the common questions you can be asked about something like this is what kind of genetics is going on here? How are these traits being passed on? And the answer, in this case, is autosomal, so it's Mendelian's simple dominance. And in this case, the trait is recessive. So I'm sure you're asking yourself, how do I know that? Well, let's think about these parents. Let's assume that I want to use the letter D as the dominant trait, or the dominant allele, rather. And I want to use lowercase for the recessive allele. Okay? That means that number 2 here has to be little d, correct? And that means that number 1 in generation 1 has a big D, and we don't know what else. And generation 2 has a big D, and we don't know what else. Now we know they have to have the big D because they don't have the trait. And we know that this person has to be little d because they have the trait. And so that means that this has to be little d. So you may be asking yourself, well, how did I know that having the trait wasn't dominant? Easy answer here. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. There's 19 individuals in this pedigree, and 1, 2, 3, 4, 5 have the trait. It's not always 100%, but it is a good place to start. If the trait's not that common, it most likely is recessive. The other thing that you note is if these two parents were recessive, so they were both this, all right, if they were both this right here, there is no way that they could have a offspring with a different version of the trait. The only way that they can have 2 different types of offspring is if they carry both alleles. So if they were both recessive and the trait was dominant, they could never have the dominant version. So a lot of these genetics problems are being asked to figure stuff like that out. And we will do some practice for this in class. Now another thing to consider, I'm just going to very quickly clear the ink again, is how do you figure out what an individual's genotype is? Now keep in mind, you can't figure out everybody's genotype. But there are times when you can use a pedigree to figure out someone's genotype. So for instance, what if I asked you to figure out person 1, generation 2's genotype? Well, that female right there has to be big D, if I stick with that letter, and I don't know what her other allele is. I know that this person is big D, and they have to be little d. I know that the person number 2 in generation 2, who our questionable individual married, is little d. And then I look at their offspring, and see this offspring right here that's little d? Well, one of these little d's had to come from the mother, or the father. The other one had to come from the mother, so she had to be little d. And so a lot of working with pedigrees is determining how the trait is being passed on, autosomal recessive, dominant, sex-linked, or using what you do know to figure out what the genotype is of different individuals. All right, and that's pedigrees.